Hello everyone, welcome to MathsciAC. Here's another exam style question for A-level physics. Now this question is a slightly longer question with 5 marks. Let's have a look. A student sets up a circuit containing a fixed resistor and a light dependent resistor LDR connected in series with a power supply as shown in the diagram. The student moves the light source closer to the LDR and notices that the voltage across the fixed resistor changes. Using your knowledge of how an LDR works, explain why the PD across the fixed resistor changes as the light intensity increases. Include the role of electrons in your explanation. 5 marks, so you need to have at least 5 points to explain what's really happening here. Think about the question, pause the video, give it a try, jot down what points you would write, and then you can press play and compare it with my answer. So let's see what sort of points we can come up with for this question. As the lamp is moved closer to the LDR, the intensity of light increases. Now that's obvious. When you bring the lamp close to the LDR, it gets a greater intensity of light. So electrons in the LDR gain energy from the light and break free. So this light is a form of energy, so the electrons absorb energy and they break free. This increases the charge carrier density. So when there are more free electrons, the charge carrier density N increases. Remember, because this happens because the LDR is a semiconductor. So the resistance of the LDR decreases when there are more charge carriers per cubic meter. The resistance is now less. As the PD is proportional to the resistance according to V is equal to IR, the proportion of PD across the LDR decreases. Now this one is a really important point here. So initially, whatever the PD that you have across this one, say this is V1 and this one is V2 and this one is capital V. Now whatever happens, the value of V is V1 plus V2. Now as the PD is proportional to the resistance according to V equals IR, the proportion of the PD across the LDR decreases. So the resistance of the LDR decreases. So LDR has V2, so V2 will go down. Now the total of V1 and V2 is the same. So when V2 goes down, naturally V1 will go up. So we can say the PD across the fixed resistor then increases. Right? Now if I just put some simple numbers, imagine this is 6 volts. Let's say initially this was 4 volts and this one is 2 volts. Now when the light intensity increases, the resistance of this one decreases. Now this one goes to say 1 volt, but the sum is still 6. So what will happen? Obviously this will go up to 5 volts. That's what it says. So here are the points you can write to get 5 marks. As the lamp is moved closer to the LDR, the intensity of light increases, will get you 1 mark. So electrons in the LDR gain energy from the light and break free is another possible point. This increases the charge carrier density N is another point. The resistance of the LDR decreases is another one. As the PD is proportional to the resistance according to V is equal to IR, the proportion of the PD across the LDR decreases. So the PD across the fixed resistor increases. Now you got 6 different points here. To get 5 marks, if you write 5 valid points, you should get full marks.